Hello and welcome to another episode of Algebra 2 Notes with Miss Faust. Today we're going to be looking at notes for lesson 713.4. Hopefully you got this worksheet in class and you'll be able to just fill it out and sort of annotate it as we go. That was the idea. And all of the things that we're going to be looking at today have to do with compound interest, which is generally has to do with money. So I have an appropriate joke to start. Why is money called dough? Because we all need it. Good one, right? Okay, so speaking of needing money, let's get started. When you put money in the bank, it earns interest. Interest means that a certain percentage of your money is added to your account periodically. It could be added each year, each month, each day, each minute, continuously, each hour, twice a year. There's lots of possibilities. But however many times your money is getting added, that's the interest getting added. Another way of saying that is we say it's compounded. So it's compounded frequently, and this is called compound interest. So we're going to start by taking a look at a pretty simple example and just build up the table and see what happens. So if you have $4,000, you deposit into a bank account, and the interest rate is 8%. So the question is, how much will you have after 4 years? So what you have to remember in these is that at the end of the first year, you're getting interest. So you're going to have more money at the end of the first year than you did at the beginning. So it's not just the very end of 4 years when you get money, it's every year. So what we can do to figure out the interest rate was 8%, but 8% we have to change into a decimal first. Remember, to change a percent to a decimal, we go back 2 spaces. Let me see if I can adjust the color on this a little bit. I don't know why it's getting so bright and hard to see. That might be better. So anyway, interest rate is 8%. So you're getting 8% of 4,000. So to figure out the interest, we do 4,000 times 0.8, and 4,000 times 0.8 I had done somewhere, but of course I lost it. So I'll just get out my handy calculator and do it again. Ooh, that's too bright for you. I'll do it off screen. Magic is happening. 4,000 times 0.08 is 320. So at the end of the year, you have $4,000 plus 320, or $4,320. So at the beginning of year 2, that's when you have $4,320. Now for the interest, we take that number and multiply it by 0.8, because we're getting interest on all this money, not just the money we had in the first year. So we do 4,320 times 0.08, and we get 345.6. You can see we get a little bit more interest in the second year. So we take 4,230 and add 345.6. 4,320 plus 345.6. 4,665.6. I'm going to put a 0 at the end since we're talking about dollars. So at the end of year 2, beginning of year 3, we have $4,665.60. We multiply that by 0.08 again, and we get $373.24.8. I'm going to make it 25. So 4,665.60 plus 373.25. $5,038.85. It's growing pretty fast, right? 8% each year. And then here, 5,038.85. Oops. So I need that times 0.08 again. That year I'm getting $403.11. So I have $5,441.96. That's pretty good. Interest rates, by the way, are not nearly this high. We're just using this as an example. But that was kind of tedious, right? So each time what we did is we took our initial amount, so 4,000, we multiply it by our interest rate. Interest rate's always staying the same. And then we're adding that interest amount that gives us the new amount that goes back over here. So this 4320 went back to year 2. We put the 4320 there. We do the same thing. So we have to repeat that iterative process. Not the easiest thing in the world. So as you can imagine, it gets tedious, especially if you had this money in a lot of years. So this formula right here, a little bit hard to read on the screen, but you have it on a piece of paper in front of you. This equation gives us the amount. So each of those letters stand for something different, and then we'll do some practice plugging them in. As some of you have started to notice, this unit is a lot of plugging things into formulas. So once you understand the formulas, you can get a pretty good grasp on how things work. So A is the amount at the end of whatever time period you're talking about. So it's the amount that your money's worth after all the time passes. P is what we call the principal, or the initial amount of money you put into the account. P for principal. R is your rate of interest. And you want to make sure when you're using R in this case, you always have to change any percents to decimals first. So whatever percent you have, you make it a decimal, you put that in for R. N is the number of times per year the interest is compounded. And we'll look at examples of that in a second. And T is the number of years that you're leaving your money in the account. So this is a P, a 1, R, which is your rate of interest, over N, the number of times per year your interest is compounded, to the power of that number times T for years. So we can just try that with the example that we did before, where we invested our money for 4 years. So the A equals and I like to put that multiplication sign in there so I remember it's there. A is what we're looking for. Our principal is 4,000. So that's what goes there. Times 1 plus R was the 8%. So 8% we turned into, remember we already turned that into a decimal and it was 0.08. So I put 0.08 here, divided by N. Well, in this case, we're just getting interest once a year, right at the end of each year. So N is 1. Put that over there so we know it. And then our T is this 4. So R is the 8, P is the 4,000. Just have it annotated nicely for you. So N times T up here is 1 times 4. So the one thing you want to be careful with in this formula is respecting order of operations. So inside the parentheses has to happen first, then the exponent, then the multiplication. So if I do 1 plus 0.08 divided by 1, and just so you can see, that's what that looks like. Close parentheses, enter, 1.08. So I get 4,000 times 1.08 to the power of 1 times 4, which is 4. Now I'm going to do 1.08 to the power of 4, because my exponents come next. So I have 4,000 times 1.36 and a bunch of other stuff. You can fill in more decimals if you want. My calculator's full of them. So I multiply those numbers, and I get 5441.96. Okay, even though it's the very first time we use the formula, probably still took us less time than building this whole obnoxious table up here. But I just wanted you to see, like, it's important to understand why formulas are useful and also where they're coming from. So that's why we did the table first. So if we just take this and we change it a little bit, so if you look at the next question, same $4,000, same 8% interest in the bank for 4 years, but this time our interest is compounded monthly. So our P is still 4,000, our R is still 8, our T is still 4, but monthly means our N this time is going to be 12. So when I plug those numbers in, I get 4,000. 1 plus r, 0.08, divided by n. N is 12, to the power of 12 times 4. So 4,000, do the part in the parentheses first, 1.006, repeating a whole bunch of times, 7, and then 12 times 4, I guess 48, yeah, 48. Now I need to do that exponent. So I do the 1.00666, all that, to the power of 48. And I get 4,000 times 1.3757. I'll round it to. It's a 6 with some other stuff. And I'm not, like, I'm keeping this in my calculator and timesing by 4,000. So my answers might be a little different than if you just do 4,000 times this number, because mine has 6s and 7s and more going on there. 5502.66. So you can see it's not a lot different, but you know, it's $60 more. So given a choice, you want the more frequently compounded interest. So some common numbers used for compounding periods: semi-annually means n is 2, quarterly means it's 4, monthly means it's 12, weekly is 52, daily is 365, hourly is 87.60. And you can see that those numbers are getting bigger. As those numbers get bigger, the amount of money that you have will get to be more in the same number of years. Okay, so let's look at another example. You can just turn your paper over. Must be nice not to have to write everything out, right? Just to have it right there in front of you. So in this example, you have a generous grandma. Your grandma buys a $1,000 savings bond for you on the day you were born. It earns 5% interest. You'll cash out the bond after 18 years. So what we're going to do is we're going to do this problem 3 times. One for annually, one for monthly, and one for daily. So in all of these, our P is 1,000. I like to just keep track of those things. Our R is 0.05. Our T is 18 because we're leaving our money for 18 years. If it's calculated annually, N is 1. Monthly, N is 12. And daily, N is 365. So A equals 1,000. 1 plus 0.05 over 1 to the 1 times 18. Or A is 1,000 times 1 plus 0.05 over 12 to the 12 times 18. Or A equals 1,000 times 1 plus 0.05 over 365 to the 365 times 18. So I'm going to stop there for a moment. I'd like you to stop, plug all that in your calculator, see what you get, and then keep playing, and we'll see if we got the same things. So if you didn't get the same thing, you'll want to maybe highlight that and come back and talk to me about it next time. But first, pause. So now that you've tried those on your own, hopefully you got answers close to what I have here. It's going to be really important that you actually try putting this in your calculator and getting the answers on your own. Rounding errors are really common in these, and they can make a huge difference in the answers that you get. So for example, if you do this inside the parentheses and round it to like only 2 decimal places and then do the exponent and then multiply, you're going to get a really different answer. So be aware of that. Don't round until the very end. That's the general rule for these. And if you need some help with how to do that on the calculator, just come talk to me next time and I can show you. It's really easy to keep all the digits in the calculator as you continue. So you can see that the more often we compound the interest, the more money you get. Not by a lot, but a little bit. So usually what happens though is you don't have interest that's compounded only a few times a year. You have what we call continuously compounded interest. And when you have it compounded continuously, it means that every instant, all the time, your money's earning interest. If you think about it, that would mean n was infinity. We can't put infinity into the equation, but there is a number that we use that has the same effect as putting infinity into the equation. It changes our formula slightly, and that number that we use is called E. So here is a formula for E. E is equal to this for a really large value of x. Usually the way we talk about it, though, is E is this big long decimal. So like pi, E is an irrational number, cannot be represented by a decimal or fraction. It's used all the time, though. So if you look at a calculator, your calculator will either have a button that looks like this, e to the x, or it'll just have an E on it, or it might look like that. So if you look at a calculator or your phone, if you usually use your phone, look for the e to the x button. I'm going to show you where it is here on these calculators from class. So if you look, here's the second button, here's the log button, the ln button. Right above it, it says e to the x. And I realize that's a little bit hard to see right now, but when you get to class and you start using it, you'll figure it out. So you don't ever need to know what the decimal equivalent is. You don't ever need to know this formula. You do need to know where the E is on a calculator. And if you're using a computer, the letter E works in calculations as well. So when you have an interest rate compounded continuously, we skip the other formula and we go straight to this A equals P times e to the RT. And in this equation, just like in the other ones, all the letters represent the same thing. So this represents the amount at the end of t years. This represents the initial amount. This represents the number of years your money was in the account, and R represents the interest rate. Again, remember that it has to be a decimal, so we always convert from percent to decimal first. So if we look at that, just to think about that same example with your savings account from your grandmother, if you were continuously compounding, your formula would be A equals P times e to the RT. So it would be the initial amount, and that one was 1,000, times e to the 0.05 times 18, because it was 18 years. So we'd plug that in. I like to do the e to the RT part first. So I'm going to do e to the, let's see if I can get it so you can see it. It's hard sometimes with the lights in the classroom. This might not work. E to the 0.05 times 18. Notice there's parentheses at the beginning of the 0.05 times 18. Those didn't show up. You'd want to hit the parenthesis key before you did that. And I get that. So I want to take that and I want to multiply that now by 1,000. And when I do that, I get 2459.60. So 2459.60. So what that shows us, if it was continuously compounded interest, notice that the only difference between that and the daily interest is 15 cents. So daily versus continuous is not that big of a difference, but you know, when we're talking about money, every penny counts. So to do another example, this is using current interest rates. Currently, the interest rate is 0.06%, not very good. So if we think about this and a $500 bonus, the principal for this then is 500. The R is this with the decimal place moved back 2 spaces, so 0.0006. And then it's giving us different values for T. Because in this one we don't have an N to worry about, so we can do each of these. So for 1 year, the amount equals, 500 times e to the 0.0006 times 1. For 5 years, it would be 500 times e to the 0.0006 times 5. And for 10 years, it would be 500 times e to the 0.0006 times 10. You can't see them all at once, but that's okay. I'll show them to you in a second. So let's do those calculations. I'm going to move this up a little so you can see the buttons I'm punching on the calculator as I do it. Maybe that would be the ultimate goal, but wait a second. I have an idea. Live action films here, guys. Sorry. So, okay, so 500. And notice You can put it all in your calculator at once. 500 e to the 0.0006 times 1. That gives me $500.30. 500 times e to the 0.0006 times 5. Just using the up arrow and scrolling back through this so I don't have to type it all in again. Change the 1 to a 5, and I get 501.50 in 10 years. So again, I just use the up arrow to get the exact same thing in. Change the 5 to a 10, and I get 503.01. Okay, so you can see that 0.06% interest is not very good. After 10 years, you'd only have $3 extra, so you probably want to just go spend your $500 bonus. When will your investment be worth $500? That's actually a typo. I meant to make that $550, so you can change that. $500, yeah, it's kind of always worth $500. I don't even know if it's going to be worth $550, but what we're going to do to look at that is we want to think about when $550 equals 500 times e to the 0.0006 times t. In order to do that, we're actually going to use a graph, and I'll show you that on Desmos in a second. But the two equations we're going to graph is we're going to graph y equals 550 and y equals 500 times e to the 0.0006 times x. So if we graph both of those and we find where they intersect, that'll tell us when our investment is worth 550. So if my camera doesn't fall over, I'm going to switch now over to, I'm having all kinds of trouble. Let's just switch to Desmos. Hopefully you've got those written down, so when I start graphing them, you won't be like, where is she getting these? Okay, so you go to Google or whatever your web browser is. You go to regulardesmos.com. Takes us to a calculator. And the first equation we want is y equals 550. The second one we want is 500 times e to the 0.0006x. So first when you look at that, notice nothing really shows up. Well, I'll close that, and I will also zoom out a couple of times. And if I keep zooming out, I mean, obviously this isn't going to show up because 550 is way more than 100. But as I get out, there it is, towards 500, you can see that my graph shows up. So those buttons, zoom in and out, going to be important when we do these. And now all of a sudden we can see where both the lines are. So what we just want is to see where they intersect. So where they intersect, x is 158.85, y is 550. So what that's telling us is that when x is 158.85, our investment's worth $550. So it takes 159 years basically to get to that amount. So here x equals 159 years. Okay, again, probably not the best investment of your money. That's why people talk these days about stocks and real estate and things like that. But we can talk about that more in class. We'll also do some more practice with these graphing ones, so you have a chance to do it on Desmos and get the hang of it. Okay, thank you very much. Have a wonderful day.